All right, so here is 9.3. We're going to do this in Zoom. So if you've done the lesson in Zoom with me, there's no need to watch this video unless you want a reminder. But yeah, but if you were not in Zoom, then make sure you watch this full thing. It's really just on more on slope and then realizing that a linear function has a constant rate of change, which means that it forms a straight line when graphed. So we are on page 133 in our consumable. So we, in this lesson, are going to be able to show that a linear function has a constant rate of change. We are going to be able to understand when the slope of a line is positive, negative, zero, or undefined. And we are going to be able to identify functions that do not have a constant rate of change and understand that these functions are not linear. So just going straight to the lesson. So it says, you have seen that for a linear function, the rate of change is constant and equal to the slope of the line. So linear function, the rate of change is constant and equal to the slope of the line. So what that means is that my slope is going to remain constant throughout my function. So it's going to form a straight line because my slope won't be the same. This is because linear functions increase or decrease by equal differences over equal intervals. So it says, look at the graph below. So it says over the interval 2 to 4, when x is 2 to 4, how much does the function increase by? Well, we go up 1 between those 2 to 4, so an increase of 1. Then it says, what is over the interval 8 to 10, how much does the function increase by? Well, again, up 1. So what we have are equal differences over equal intervals. So my y differences is 1 over my equal intervals of 2. So equal differences over equal intervals is an equivalent way of referring to constant slope. Differences, which refers to my change in y, and intervals refers to change of x. Equal differences over equal intervals means that change of y over change of x will always be the same. So let's look at that. So it says the table below represents a function. So each input goes to exactly to one output. Then it says determine the rate of change between the points negative 8, 62, and negative 6, 34. So my rate of change is my slope, which is my change of y. So 62 over 34, or 34, 62 minus 34, over my change of x, which is negative 8, negative 6. So that means my change of y would be 28 over negative 2, which would be negative 14. So the rate of change between those 2 points is negative 14. So it says, then determine the rate of change between the points negative 1, and 1, negative 1. So change in y is 0 over my change of x, which is 2, which 0 divided by 2 is just 0. So the rate of change between those 2 points is 0. So it says, is this a linear function? Justify your answer. So since their rate of change are not constant, so no. The rate of change is not constant. So we can know that a function is a linear function in a table if the rate of change is constant, or in a graph if it is a straight line. So the rest of the lesson just has us determining the slopes of different lines. So I'm actually going to pause this here and do the answers, and then I want you to pause it as well. You're going to need to pause or else my video is going to keep going. I want you to pause it here and find these slopes and then see if you were correct. All right, so the slopes of these are 1/4 because we go up 1 over 4, 2 because we go up 2 over 1, and then 5 because we go up 5 over 1, making sure that you pick nice points to find the slope between. So it says, then describe the slope of any line that rises as we view it from left to right. So as we go into the negatives and go towards the positives, what can we say about this slope that of the line that rises? Well, all my slopes are positive. We're increasing, so the slopes are positive. Positive slopes. If we're looking from left, if we're looking from left to right, and we're going up. Our y values are increasing. We have positive. Let's look at this one. So let's do the same thing here. I'm going to pause my video. You pause it as well. I will then do the answers, and then so it's going to pop up shortly. So make sure you hit the pause button. All right, so the slopes of these ones are shown up above. So the first one, we go down 3, right 1. So my down makes it a negative, so it'd be -3. My second one, I go down 4, right 2. So that going down makes it a negative, so -4/2 or just -2. And then the last one, I go down 3, right 4. So since I'm going down, that's also negative. So then it says, describe the slope of any line that falls as we view it from left to right. So as we go from the negatives towards positives, if our y values are decreasing, looking at my slopes, looks like all my slopes are negatives. So negative slopes. So if we're going down, we have negative slopes. All right, so let's do the same thing. Determine the slopes of the line below, and then see if you can summarize what's the slope of a horizontal line. All right, and it is actually the case that all of these slopes are actually just 0. Picking 2 points, it doesn't matter. My rise, well, I don't have to rise, so my rise is 0, and then my run would be whatever the difference in the x values is. So 0 divided by 2 is actually 0. Same with this one. We don't rise at all, but we can run. So 0 divided by 4 is 0. And same with this last one. Don't rise at all. So my rise is 0, but I can run. So 0 divided by 1 is 0. So the slope of a horizontal line is 0. All right, now we have vertical lines. And I'm actually just going to stay and walk you through this in the video. So again, picking 2 points, it doesn't matter. And then doing my rise over run. Oh, one thing I want to point out, for all of these graphs, all your equations are going to be y equals your y-intercept. So where does it cross the y-axis? Because that your y values are not changing. So this one would be y equals 1. This one would be y equals 4. And this one would be y equals 2. Because we don't have a slope of, we don't have that mx. So our slope is 0. So it's just our y-intercept. All right, back to my vertical line, sorry. So I'm going to do the same thing, rise over run. So between these 2 points, I need to go up 3, but my run is 0. I don't go left or right. Now, if you have a calculator in front of you right now, do 3 divided by 0. When you do 3 divided by 0, it's an error. So this is actually undefined. And that is the case for all of these vertical lines. Any vertical lines have an undefined slope because we don't have that run. So these are all undefined. So the slope of a vertical line is undefined. And your equations actually differ as well because your y value, it doesn't matter what y is, your x value stays the same. So all of these equations are actually x equals equations, so not even y equals. So this would be x is equal to -4 because anywhere for this function, your x value is -4. This one would be x is equal to -2 because anywhere on that line, your x value is -2. And then this one would be x is equal to 3 because anywhere on that line, your x value is 3. So let's summarize this up. So it says summarize your findings in items 4 through 7. Tell whether the slope of the lines described are positive, negative, 0, or undefined. If we're going up from left to right, those were my positives. So we're going up. If we're going down from left to right, those are my negatives. My horizontal lines, those were my 0 slope. And my vertical lines, those are my undefined.